Hey, sorry I'm getting this out to you pretty late, but I got held up at school, so for whatever reason, early dismissal days, I don't get early dismissed. I have end up having a lot of work at the school to get done. So I'm home now, and I'm recording the continuation of the video that we started on the weekend, which was about looping over strings. And I want to close off with the example that we had last time, which was looping over swapping adjacent letters in a string. And our solution that I ended up coding in IntelliJ. So here's the solution we have: swap adjacent characters. And we're looping string.length divided by 2 times. We're getting the first letter and then the second letter using these indexes 2 times I and 2 times I plus 1. And then we glue them in the reverse order like this. So let's see this work. And we've got our string Seattle, and we want to swap adjacent letters, so we should get ES, ES, TA, and then LT. Oops, and we're missing a letter at the very end. So let's see what's going on. Why are we missing that letter? Those of you that may have been paying attention to the fact that we divided by 2, in Seattle is an odd number of letters. This actually skips the last letter. So we have a slight error, a slight off by 1 error, and we could fix this a couple of ways. One way to fix this is to, well, if it's an odd length string, just glue the last letter on at the end. So that's a pretty easy way to solve this problem. So we'll go ahead and do that. If str.length mod 2 equals 1, so that means we have an odd length string, then what we'll do is we'll glue the last letter on, swapped plus equals, str dot, how do I get the last letter again? Well, that's str.length minus 1. That would be the last letter of the string. So let's go ahead and double check to see if that fixed our problem. Seattle, with all of this letters swapped around, is now as stout as we expect it to be. ES and then TA, and then LT, and then the last letter E. So we wouldn't have run into this problem if we had done it with an even length string. We would just not have noticed that this was a problem. So if we had done Mushi, which is a string of 6 letters, then we would have gotten the correct behavior, which would be OM SOIH. Okay? We wouldn't have noticed it. So I'm going to go ahead and just take this fix out, and we would still get the OMSOIH behavior as we want it. So it only gives us an error if, only doesn't work correctly if the string has an odd number of characters. Okay, so let's look at another way of doing this problem, another approach to solving this. And don't forget in your notes to adjust this so that you get, if the length is odd, str.length, mod 2. This is how you determine if it's odd. Mod 2 equals 1. Then we would, glue last letter. And these kinds of errors you actually come up commonly. They're little off by 1 errors where you're almost correct, except that you forget that sometimes it doesn't work exactly how you expect. The easiest way to find these errors are basically testing your programs and making sure that it does the behavior you expect it to. And then analyzing, well, why didn't that work correctly? Why didn't that give me what I wanted, what I expected. And in this case, we divide by 2, and if it was 7 divided by 2, that ends up giving you 3. And so we only do 3 swaps, and so we're only going to be ending up looking at 6 letters in total. which there's 7 letters. And so, all right, um, let's look at another approach to doing this. I don't know why I would say answer 1. This is answer 2. Okay, so the other approach to doing this is to go by, is to make our I loop counter go by 2s as opposed to going by 1s. So the last time we went by 1s and then we computed the index we wanted, the character of the index we wanted. And this approach is going to be having the loop go, having the loop counter be the index we want. So rather than the loop counter just chugging along 1 at a time, we know that we're jumping every 2 letters. So we're starting at index 0, and then we skip index 1, and we go to index 2, and then we skip index 3, and then we go to index 4. And so we're jumping every 2 characters. We're looking at pairs and then going to the next pair. So we can have our loop counter variable handle that by jumping every 2. So now what we're going to do is go actually 1 less than string.length. The reason why we don't want to go to string.length exactly is because if we do end up jumping to the last index, and then we're going to go off the end of our string, basically. So we don't want to go off the end of the string. And we'll see that it doesn't work. And this really only is going to be an error with odd length strings. So we'll see why this comes up with odd length strings when we test it in IntelliJ. So now we get the first letter, which is at I plus 1. So 0, 0, 1, 2, 1, 4, 1, or 0, 1, 2, 3, and 4, 5. Those are the first letters. That's S, A, and T. We get the second letter, which is 1 past that one, so I plus 1, I plus 2. And we glue them in the reverse order, just like we did the last time. So the main difference between this, this way of doing it, and note we're also going to have to glue the last letter. So we have to glue last letter if it's an odd length string. Last letter if odd. We haven't taken care of that yet. But in this case, we're not computing the index inside. We just use I for the index we want. Index. All right. And so the math is being done basically inside the for loop header, and not actually in the for loop body. And so that's another approach to doing this problem. So let's go ahead and code this up, and we'll see why this string.length minus 1 is important for odd length strings in a moment. Okay, so we'll go ahead and change some things around in our swap adjacent characters code. So now we're going to go string.length, and we're going to go up by 2s plus equals 2. And then we're just grabbing the ith character for our first letter, and we're going to grab the I plus 1 character for our second letter. So this should work as we want it to. Except remember I said that we need that minus 1 here. So first I'm going to take the minus 1 out, and let's see what happens when we do that. And we're going to get an error. So boom, see, we immediately, our program went kaput, and we got a string index out of bounds error. So this is a good thing. Errors are good. They mean that our code isn't working as intended. So we should try to figure out why this is why this error got thrown. So note it says string index out of range 8, meaning we were trying to access the index 8 of a string. So we could, let's go ahead and just pop into the debugger and walk through the code and see what, when this gets thrown. So I put a little breakpoint here at this for loop, which is going to be useful, because this is where I think we're going to have our errors, is every time this for loop, right when we start this for loop, we're getting an error. So, all right, so we're going to debug and walk through. So we've got our string Seattle, and our string swapped is swapped. And then we're going to just start stepping through the code. So note it's keeping track of the for loop counter for us. I is equal to 0. It's going to keep track of first letter, which is S. That's great. Second letter, which is E. And then swapped gets ES. So far, so good. We swapped the first two letters as we wanted to. We're going to walk through the for loop one more time. Now we have AT, and we swap those letters, and so we get TA. So far, so good. Now we're going to get T and then L. We're going to swap those. That's LT. Now I is equal to 4. Now I is 6. And we swap. We're going to get E, and then I believe here's where we get a problem. That's where the error just got thrown. So I can't back up, because now we just threw the error. But the problem is that last time through the loop, this was E, and then this one was the thing after E, but there was nothing after E. And so we actually don't want to go all the way string.length times. We need to do it one less than string.length times. And this will fix this problem, because now we're not going to go off the end of our string. So let's go ahead and give this a test run. And as we wanted, it gives us a staltz and then mushy skipped around. So this if statement, I think, is still necessary. If we don't have this, then we're going to miss that last letter. Yep, just like expected, that the odd length case is missing if we do this. If we don't include this, glue the last letter bit. So, all right. So those are two approaches to solving this problem. One of them, we go by ones and we compute the index we want. The other one, we go by the indices that we need to access and do all of the math inside the for loop header up here. Okay, so either approach is valid. Alrighty. So what we just saw in that last one was that we easily can go off the end of the string. It's pretty common to get these off by one bugs. In fact, off by one bug is like, this is a CS term. People run into this all the time programming, where they're like intending to go only so far, and then they actually accidentally go off the end of a list, or maybe they don't do, they get everything but the last item or everything but the first item, and so you're basically getting it right except missing that last little edge case. And so I'm going to give you an example of how this can easily crop up in your programs as well. So this is a programming error. If you go off the end of a string, you want to avoid doing that. If your code does this, then it stops the program right then and there, right when it hits off the end of the string. So it's not going to know ahead of time if you're going to go out of bounds. You'll only catch it when you're running the program. So here's one way you could have gone off the end of the string. So if you start at 0 and you go less than or equal to string.length, or if you started at 1 and went less than or equal to string.length, then you're going to go off the end of the string, because remember the last position is at string.length -1. And so when you try to access, when I equals the length of the string, you're accessing the thing that's off the end of it. And so that's invalid and it throws an error. So in either case of starting at 0 or starting at 1, this won't work. Okay, another thing you might run into, which is similar to this off by 1 error, is called a fence post problem. And a fence posts, like if you're planning fences, you have a series of posts with wires connecting each of these posts together. And when we're doing loops, we're oftentimes repeating one or more things. Say you're like planting a post and then stringing a wire, you plant a post and string a wire. So imagine you were telling a computer to do this, you would write like a for loop. Plant a post, string a wire, right? Do it 100 times and you've built a fence. However, the problem is that you've done this. You've planted a post, you've strung a wire, you've planted a post, you've strung a wire. You're repeating this 100 times. And at the end of the day, you know, here's your 100 posts with wires. What do you end with? Well, you're going to end with a wire that's just going off to nowhere because you've said plant post, string wire. And so the last thing that you're doing is stringing a wire. And so you've got this weird hanging, you know, wire off to nowhere. So there's a couple of ways to fix this. We'll talk about both ways. So here's a scenario. Suppose you want to just take a string and add commas. So you're just putting commas between each of the characters. So like foo is going to be F comma O comma O. So you're just coming up with a list of each of the characters that make up that string, and you're separating them with commas. So here's an attempt to doing that. We start off with an empty string, and we're going to glue each letter. So we're looping over each of the letters, starting at 0, going less than length. We're gluing that letter followed by, and then a comma with a space. So you can think of the letter as a post. This is a post, and then this is a wire. I'll just say post. This is a post. And then these commas are the wires connecting each of the posts. And so what do you think is going to happen if we were to run this code? Well, here's your output. You're going to get F, comma, O, comma, O, comma. And that's not quite what you want. You've got this weird extra punctuation hanging off the end. You really want it to just do F, O, and then O. And so a couple of ways to fix this are either you save the last comma, so the last letter you're going to handle afterwards. So this would be planting the post at the very end. Or you plant the first post at the beginning, and then you reverse the order that you do these letters and commas. So let's look at those two different options. Okay, so how are we going to fix this? We're going to look at those two approaches right now. Okay, so like I was saying, you can think of each of those letters as posts and each comma as a wire, stringing one letter to the next. And we strung one too many wires, right? We did a post, comma, or a letter, comma, letter, comma, letter, comma. So we ended with a comma when in fact we just wanted to end with a letter. So here's one way to fix this. You plant the first post before the loop, and then you start the loop at the second post, right? You don't want to start at the first post, you want to start at the second now. And then you reverse the order that you are planting things, right? So now you're doing wire, comma, post, or wire and then post. So in this case, we would do the F first, so that's planting the first post, and then we would do comma, O, comma, O. And that way, we end with planting a post, which is what we want to, and not stringing a wire. And so the switching of the order is going to fix that. The other way to approach this is to loop the usual number of times minus 1. So you loop one less time. So you plant all of the posts and wires except the last one, and then you plant the last post after the loop. So in this case, what you're doing is you're doing F, O, F, O, and then F, comma, O, comma, and then you're gonna pause, you're done with the loop, and then the last time you plant the last letter, O, so you're gonna do the last letter afterwards. So let's look at those two solutions in Java. So in this case, we grab the first letter, so this is the first letter, So we start our empty string now as just the first letter, and then we start our loop The loop starts at 1 instead of at 0 because we want to start at the second letter with the loop. And then we reverse the order. So our order got swapped so that now we're doing wire and then post. Okay? So we've swapped the order around. So we do comma followed by the letter. In this way, we're going to end with the post and everything will be good. We'll be doing what we want to be doing. Okay, so the other approach. So this was the plant the post and then reverse the order, start at the second post, and you'll be done. The other method is to do the usual order one less time and then plant the last post outside. So what's that going to look like? Start with an empty string, do the usual order. Oops, here's the usual order, right? String, the first letter followed by a comma, or the ith letter followed by a comma, and go one fewer times. So this is now where things got a little bit different. So we miss the last letter on purpose. So in this case, we are on purpose not doing the last letter, and we plant that last letter, we plant that last post afterwards. So this is the last letter is added, right? So either of these approaches are going to work. It's kind of personal preference which way you tackle this. Just know that a fence post problem is going to be a common problem that will arise when you're working with loops, when you're trying to do something some number of times, and if you accidentally do it one too many times, then it's because of the fence post. Okay, so I believe that's it for my slides. Tomorrow we're going to start our Caesar Cipher lab, which I don't believe has too many fence post problems. It may or may not show up in there, but it definitely shows up on the AP test, and we'll do some problems where it's going to pop up. So anyway, hopefully you learned something in that video, and I'll see you guys in class tomorrow.